Hey everybody, this is Larry. This is me going with Q4 of the weekly contest for 13 maximum XOR score Subarray queries. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. This one is very tricky. As you can see, not that many people have gotten it. Well, maybe I update. Yeah, okay. Well, actually, a lot more people gotten it since I. Okay, but yeah, still not many people gotten it. It's a very tricky problem, but and I think the first thing that I would say is that if you're looking for a problem type, yeah, okay, maybe it's dynamic programming. There are dynamic programming components, but it is honestly the DP part is pretty straightforward in terms of DP anyway. It's not it is a prerequisite, but it is not, the harder part of the problem. The harder part of the problem is that this is a problem-solving problem, right? This is an analysis problem. This is an observation problem. You have to figure out what the problem is asking. You have to analyze it, and you have to figure out how to come up with a strategy for it, right? And if you could watch the live portion of it, right, because I did this in about 37 minutes, and I played around with a lot of stuff. You'll see me play around with a lot of stuff by writing the brute force way. The first thing I would say is that, and I thought this was surprising, that XOR score is actually some funky thing, right? It is this like algorithm that I did not look at for the first 5 minutes or something like this, because I was just like, oh, I just thought that I had to get the subquery of the thing. I don't know why they call it XOR score, because it's just I don't know, I guess they define it that way, but they could have just said like maximum score, right? Where there is an XOR function. Calling it XOR score, I don't know. It confused me. I just thought it was maximum subarray XOR. So, okay. So once we did that, we have to figure out what this algorithm does, right? And the way that I did it, if you watch the live portion of it, is that and you can watch the live portion of it, of course I'm explaining it here, is that I just wrote a brute force method. I actually didn't save it down, but I mean, it's not that hard, right? You just write an n square kind of thing that generates it one row at a time to see what happens. And one thing that you can do to kind of figure out the contribution is actually just pass powers of twos, which actually is example one. But if you kind of write it out, right? Let's say you have I don't know, a number of digits, right? A1, A2, A3, A4, A5, right? And then you just kind of write it out. That's the way that I was trying to think about it. Now that I saw that this is a specific thing, and I was like, okay, wait, this is not just getting XOR of all the numbers, and in fact, I verified that it was not that. Then I can just do XOR X. After one iteration, so this is after, this is initial, so 0 iteration. After one iteration, you have this, right? A1, A2, A2, A3, A3, A4, A4, A5, right? And then after two iteration, you have, I don't know why this extra space here. A0, A1, right? And then ... right? And then here, okay, that's actually not ... This is, right? Let's do a few more, and then we could ... these, right? And the thing is that, okay, so we did it this way, and maybe you could say that these kind of cancels out, and that's what I did, right? I kind of looked for a pattern, and actually I couldn't figure out the name of this triangle in the beginning, but it is actually a very cool triangle if you kind of visualize it in terms of zeros and knots. I just googled this. It is not important in the sense that it doesn't help you solve the problem. But it is kind of cool if you're a math nerd like me, and you're like, oh, there is a pattern. And I was like, oh, there's the I forgot, I said something else, but I knew that was like this Sierpinski's triangle type thing. So you could kind of figure it that way. And I couldn't figure it out, honestly, right? I mean, like, yeah, you could kind of say these things cancel out, and then the next one is going to be, let's just say it canceled out anyway, right? So so then now it's going to be A1, A2, A3, right? A1, A2, A3, A4, and so forth, right? Yeah. So, and there is some dot 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 here, and I think the first thing that it took me a while to get this, by the way, is by no means quick, because after I realized what I had to do, it was very quick. So 37 minutes of that, I don't know, you could watch the video to see how long, but like in my mind, because I didn't watch that part yet, I probably spent 30 minutes on analysis and like 7 minutes on coding. Maybe not, maybe a little bit more on coding just to kind of get it correct, because I had to do some indexing magic, but otherwise, right? But the thing to notice is that, and maybe we'll do one more, right? So 4, we have, which is this, XORing that, so it's going to be A0, A4, right? And then A1, A5, right? Dot, dot, dot. And it turns out these values don't really matter. The way that it took me a little while to figure this out. What I actually did in analysis, right, is that, okay, wait, let me step back for a second. N is 2000, right? So yeah, let me step back a second before I jump ahead. But N is equal to 2000. We know that we can do N squared processing, right? The thing is that Q is 10 to the 5th. So what that also means that we cannot do O of N per query. Maybe we can do O of log N per query, but maybe O of 1 per query, right? I mean, well, O of 1 we can definitely do, but if we're able to get to O of 1, right? I forgot to set these constraints, so let's, this is the idea that I operated with looking at the constraints. My apologies, because I was focusing on this cool part, right? And the reason why I just did serpentine triangle is that you look at just like, for 0, it's going to be 1. For 1, it's going to be 1, 1. For 2, it's going to be 101. For 3, it is 1, something like this. And then, and then you kind of like, it's kind of like a very, it's very cool. I don't know, for some definition of cool, if you're a nerd like me, right? So yeah, if you kind of look at the first term and all the binary representation of the first term, it actually looks like that. But again, this is not important, it turns out. I was just playing with the problem, coming up with the idea, right? So yeah, so okay. So what did I do? The thing that I've noticed, and a little bit later, a lot later probably, right, is that when I was kind of looking from here, going from here to here to here to here, what am I doing, right? And as soon as I got that, I was like, oh, that's smart. Which is that if I look at these as elements, keeping in mind that, okay, well, yeah, well, let me step back for a second again. So this is saying that, this is 0, this is 1, because I wanted to know, like, okay, if we have, so my initial thing was that, okay, this is 0, but that also means that length 1 possible answer, right? Well, let me put it in the bottom. Right, come here. Length 1 possible answer. This is length 2 possible answer, right? This is length 3 possible answer, because that's the way that I was thinking about it initially, because I was like, oh, length 1 possible answer, length 2 possible answer, length 3 possible answer, dot dot dot, right? Because we have to look at all the possible subarrays within a query. So then I was like, okay, then maybe I could see like how the thing is. But it turns out, right, and it took me a while to kind of realize what I was doing, but if you kind of look at these as cells, right? Let me actually, I know that I use some ASCII art, but the ASCII art is actually not super clear. So let me add some drawing thing, right? Yeah, so here, if you kind of want to put it in a table, then now you have a sub 0, a sub 1, a sub 2, a sub 3, we could dot 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 this. But then now we have a sub 0, a sub 1, a sub 1, a sub 2, a sub 2, a sub 3, a sub 3, a sub 4, assuming that we have enough space, right? And then on the next row we have a sub 0, a sub 1, a of 1, a of 2, right? And then I'm running out of room, but you get the idea, hopefully. Right? But the key thing, and this is a very terrible table / grid, right? The key thing though is that what am I doing here in total? And it took me a while because initially I was thinking about an initial array of length whatever, but now that I combined the entire picture, I was like, okay, well, what am I doing, right? What am I doing is that, say, this cell just needs based on this cell and this cell. This cell is just based on this cell. I don't know why I just circles. Okay, just maybe circles is a bad idea. But this cell depends on these two. Another way to think about it is these two. So you kind of whatever, right? This one is these two, and so forth, right? So in this way, you can actually construct all possible answers in n squared time. So that's what I was missing because I wasn't able to figure out, or I didn't even know that I need this, but that's what I was thinking about with respect to pre-processing, right? Is that, okay, I was like, okay, well, now we know the answers for length is equal to 1, length is equal to 2, length is equal to 3, and also all the way down to length is equal to n, and we can do this in n squared time, right? And it's an easy proof because there's just n square cells, and each of them you just do 2 operations. So that's step 1, right? So then now we have length. So then now what do we have? Right? What do we have here? What does each cell actually mean now, right? And of course, you have to bound check some stuff at the end, but what does this cell actually mean for after we fill it out, right? So here it means that it is starting at index. Actually, I guess we can. It's free, right? So the first column is just starting at 0. The first item is going to be 0. The first item is 1, like index 1. First item is index 2, index 3, index 4, ... right? And then the length here means, another way of thinking about it is that this is from 0 to 0. Let me change the color real quick. This is the value from 0 to 0. This is the value from 0 to 1, 0 to 2, and then 0 to 3, 0 to 4, right? ... And then so, and that's basically it, right? Now, to answer a query, how do we answer a query? Let's say we have a query from 0 to 5, right? Well, 0 to 5 is not going to be 0 to 5. So we could get the score of 0 to 5, but that's not the max subarray score inside 0 to 5, right? So 0 to 5, what does that mean? So 0 to, okay, let me rewrite this real quick, right? Actually, no, that's fine. So what cells do we care about when we are trying to answer a query from 0 to 5? Well, we care about obviously 0 to 5 one. We care about 0 to 4, but we also care about 1 to 5, right? We care about 0 to 3, but we also care about 1 to 4, and also 2 to 5, right? Basically, length 3 stuff. Right? So we care about 0 to 2, 1 to 3, 2 to 4, 3 to 5, right? So length 3 stuff, right? So that you could kind of ... it to length 2 and 1. Hopefully that makes sense. And then now what? Well, if you kind of see this process, right, of building this, now you're trying to get the maximum of all these values, right? Well, what happens? So here, the maximum value at so the way to do this is also think about this recursively, right? So here, the best value, so let's say you have the best value of 0 to 5, of range 0 to 5 is either, I'm okay, so I'm running out of space is why I'm like a little bit vague, right? So it's just this value, or, so another way to think about it is that, okay, so let's say we have some f of left and right, right? Left and right, and then which is this function that we have, right? let me rewrite this real quick. I mean, I think, okay, what I want you to focus here on this diagram is just the visualization, right? Because I think like the actual thing doesn't matter. We'll write it out. But I just want you to kind of focus on the visualization. But let's say that f of LR is going to be the XOR score from L to R, right? So then now, and let's say we have G sub LR is equal to the best XOR score, or the, you know, max, really, score from L to R. So the way to define it recursively is just that G of LR is equal to, so either it is F of LR, right, meaning that it is exact size, or so max of this, or G of LR minus 1, or G of L plus 1 R, right, recursively, right? Because then now it is saying that, okay, well, either this is our best score, changing color real quick, either this is our best score, which is a length, L being length is also confusing, but yeah, let's say this is a length R minus L plus 1 best score, or it's going to be one that is smaller by one length, right? So this is good, or recursively smaller than those, right? So that's basically the idea, and this function is the key to figuring out as well, after you figure out how to build them. Okay, I know that this is a lot. Feel free to pause and go back and change this, right? And rewatch this. I know that people have questions, but if you go back and rewatch it after you understand it a little bit better and seeing the visualization, you may be a little bit good, right? So here is how I end up doing it. So okay, and I put them kind of together, and this is kind of like very short and very tight, but yeah. So answer sub ij is, so what does this mean, right? Answer is just equal to the XOR score starting at index j with length I plus 1, right? I know I actually set this as like starting at j after I combinations, meaning I merges. So this is actually, and then best is actually, I actually fixed the index for best, which is that is equal to the max score between I and j, index I and j inclusive, right? So okay, so we start with one element, right? So this is the base case. We have one element, best of I, and I is going to be just one number because just one index, and we start answer with I thing, right? And then now here, yeah, we have I loop. I loop is of course the well, I loop is just the number of combinations, right? So like I said, or number of merges or whatever you want to call it. So after I merges, and then this j is starting at index j, right? So then here, this is what we talked about, right? With the XOR to calculate the next level XOR score, you just XOR the last two things on directly on top or previous, and yeah, and then now to convert that, and this is the other function that I was talking about, the best function, is that okay. So after j, after I combinations, so after I combinations, the right index is just j plus I, right? So this is, we set it to equal to this. It's either this or it is, one length smaller, which we calculate and so forth. And this is one length smaller on the left bound by trimming one from the left, or from the right actually. And then the next one is trimming one from the left. And that's pretty much it. I know that this is very heavy, and there's a lot of analysis in this problem, and like I said, I think this is one of those very hard problems that if you just kind of listen to me, and you may understand it, but understanding is not, like I always say, understanding is not what you're trying to get here, right? I mean, it's one of the steps for sure, but you're trying to figure out how you come up with the solution, right? And this is how, I think if you watch the live portion of it, it gives you some hints on or at least it gives you some ideas on what I did, right? I tried a couple of different things that didn't work before I saw this thing. But yeah. But overall, otherwise, and the queries just become easy because we already have everything set up. So yeah. So we just append it. This is pretty straightforward at this particular part. The code is very tight, very easy to read, but is it easy to understand? Probably not. So this is where you have to, figure out the visualization and figuring how to merge it. And it all comes, if you ask me, you have to kind of play around with this function. And once unless you're, these people, which apparently you just like do it in your head. But yeah, when you see that, then being able to pre-processing in this particular way. So if you watch me kind of write the code, initially I kept the brute force function. I verified that this matches the brute force function before writing the rest of the code, for example, so that because I wasn't 100% sure, even though I saw the visualization. The key thing to look at to see is that on the brute force function, which is kind of like this, like the brute force function is kind of this way, is that if you try to figure out this number, right? These numbers represent different things, right? Is what happens because this number is the combination of these two numbers, but also this number is the combination of, the two numbers that are on top of it, but it can also be used in the future, and there's this like reusability that comes in here, right? So yeah. Yeah, that's all I have for this one. This is going to be n squared time, n square space. I mean, the analysis I think is pretty obvious from the code, but yeah, but everything else about this is hard. So yeah, I don't know. But this is a pure problem-solving problem, if you ask me. The DP part, like this part, you definitely have to know it, obviously, but to solve it. But it also comes up in a lot of other DP problems. So for me, it was just, that. You could also think about this as RMQ, right? RMQ does this, except for that it does it in a repeated doubling kind of way. But for us, we don't even need to double it. We can just do one index at a time, which is how I kind of thought about it, right? Yeah, and this looks very tight, but not understandable unless you watch the video. So hopefully, if you do have confusions, watch it again and ask specific question in comments or in Discord. But yeah, that's all I have for this one. Let me know what you think. And I do recommend watching the live portion because I do play around with this a lot before I kind of snap. And even then, I kind of I didn't just like write all this code in one go. Like you'll see me like try to figure out how to kind of fit everything together. So yeah, that's all I have for this one actually. And thanks for watching. And you could watch me solve it live in the contest now. 10 by 10. Okay. YOLO. Okay, thank you, sir. 25 people got it. How many people got this one? 3. So we're doing good time, but let's take a look. Maximum XOR score of any subarray. Is this a tree problem? If it is, people have gotten it, I feel like. N is 2000. No, because you can you merge on the left side, right side? No. I don't know. I mean, n squared is barely out of reach, otherwise people would have gotten it, I guess. But 284 is 12. N squared is 4 million though. I'm just curious why Why this n? 4 million is not fast enough, clearly, but or shouldn't be. Otherwise, this is a very dumb problem. 4 million over 2, so it's like 2 million. Maybe it's out of memory. This is such a weird constraint. I don't know what to do with it yet. Can we do prefix sum? Yeah, I guess so, right? No. Well. So, okay, so you have a set of values and then you well, no, because there's any subarray of that bound, right? Anyone get all 4 yet? Oh, I guess so. Wow. Oh no, that's. Oh yeah. Wow. Congrats. Can you combine? Is it square root decomposition? There's a lot of things though. Yeah, even if there are a lot of queries, so you have to answer queries in log n pretty much. So no chance that it is square root decomp, which then it just becomes square root of n, which even then is too slow. So it has to be log n pretty much, or 1. I don't know how to do it without like it just straight up being 4 million queries. Maybe we can do it a little bit smarter, but that's the thing about these problems, is that like these constraints mean nothing because Leetcode's very inconsistent about how, like, it's still guesswork, right? Did people get wrong answer on this one? No, at least not those 2 people. That is incredibly fast. 5 minutes? I'm almost hesitate to think like. Can I do binary search? Not really. Can I do? And people are getting it, but I don't know why n squared wouldn't be fast enough, but oh no, it's because then now you have to. Okay, so the n squared, I see. I misread this one again. N squared, so now it's not just 0 to 3. That is easy to do with prefix sum anyway. It is every possible subset in the queries that you have to understand. Okay. I feel got it really fast. Kind of impressed actually. But the thing with XOR is that, what is the thing with XOR, Larry? It's that it is not monotonically increasing or decreasing. So that makes it a little bit weird. Can we process the queries backwards? We definitely can. Update it with 1 element. But even that's a little bit sketch, right? But we have an hour and 7 minutes. Can I focus long enough to do it? I don't know. Wait. Did I misunderstand this? Okay, let me actually. Okay, do The XOR score of an array is by repeating upon so that only one element returns. This isn't quite. This is a weird XOR query, right? Simultaneously replace a sub I with X for all indexes except for the last one. Two eight two X. Wait, maybe I didn't even read this problem correctly. The XOR of an array simultaneously replace for all indexes I. Wait, what? Okay, this isn't just getting the XOR of them, right? Then okay. Let's say we right, 7 3 2 8, right? So then now after one iteration, what does that mean? Okay, maybe then I have something here, or at least I have something to analyze, right? So okay. So then now iteration for I while length array is greater than 0 or greater than 1, I suppose. Okay, and then now new array, right? So then for I in range of length of array, we replace it with and this is -1, I suppose. Array of I plus 1, right? And then array is equal to new array, right? And then we can print array, right? Let's analyze this real quick. It's 14, which is what they tell you. That's good. And here we calc, right? But I'm interested in mode evolution. So here we could do this, right? Did I not print stuff? Oh, I didn't want it because okay. So then 14. That's not the same as. I mean, I don't know what it should be anyway, but that's not the same as that's not the same as this, right? Or this. It's such a weird way of phrasing it, though, right? Or am I just being crazy? I mean, could be both, honestly. Okay, so then, what a weird definition that they give you. But okay, I mean, maybe it's a thing, right? Because this is 4 digits. What if there's 5? Is that right? It's the same. Well, maybe that's just a weird definition. I don't know why they have this definition though. But okay. All right, Larry. Am I wrong? Or maybe I was just putting the one. Okay, so they're definitely different than just XORing the entire subsection, right? So this score does something funky. So we have to analyze this function. I totally skipped over it because I didn't know what they were asking for, honestly. It's kind of a weird thing. Okay. All right. Now we have something interesting to do. I misread this, but okay. And it's probably something like XORing two numbers or something weird. I don't know. How do I think about this? What does 11 mean to me? Okay, let's write it out. So then now, after one iteration, okay, I'll just type it out. I'm writing out too slowly. So okay, so then we start with something like this, and then after one iteration we have something like this, and we remove the last number, right? So then now, I feel like this reminds me of a problem actually. So then now we XOR these two, right? So because we XOR that, and then x1, and of course this eliminates. So then now we have these things, right? And then yeah, I mean, and then you just say A4, A3, A5, and then you kind of am I doing this right? Maybe that didn't generalize as I hoped. A1, and then you XOR it with A1 and A2, right? And then the next one's gonna be A1, A2, 2. I mean, I know that that cancels out. A2, A4, I know I'm doing it really like stupidly, but maybe I need this to help. And then now we do this with this, right? A1 and A1's cancel out, so okay, so it does cancel out, so it doesn't cancel as much as I would like, but A1, A2, A3, right? And then now these two, it's going to be A1, A2, A3, A4, and then the other one's in I can actually copy and paste a little bit, right? And then now you do these two, and then now it will be, and all of them cancels out except for this, and then all of these cancels out except for these, right? Am I doing this right? I think so, but then, and then now it's A4 to A1, A5, right? Is that right for a 6 number thing? We could try it. So we have 1, 2, 4, 8, 16, 32. So if this is right, we should have 4 digits. I don't know what that should be. 63 is definitely, oh, this is X. Okay, that's right. 51. What's 51? 51 is 63 minus 12, so minus the 4 and the 8. So it's 0, 1, 4, and 5, which is what we expect. Okay, but then how do we generalize this? A lot of people are getting it, so smart people. Not even on the first page. Okay, so it's not the XOR this thing. So okay, we don't have to care about this thing as much because apparently it is not right anyway. So then now we have 51. Okay. Then we have this thing, which is right and true. Right, so then now we have to try to max. Okay, so for 6 digits you skip the middle. I mean, we could do prefix sums about it, but I don't know. Okay. Okay, if it's two numbers, okay, if it's one number, it's just this. If it's two numbers, it's this. If it's three numbers, then we have just this, right? I think this is right. Just kind of ignore these things. So yeah. And then you have four numbers, it becomes this, which is kind of nuts. Is that true? If we have four numbers, it would be, what's that? 15. It is 15. Okay, so that's true. Huh. Do we have to calculate these bit masks for every? That's great. Okay, so it's two numbers that are one space ahead or subset of two, and then four numbers. Okay, and then five numbers is going to be this. Six numbers is this for some reason. Right. I don't know that I see a pattern, but so okay, so 32, 64. So that's for seven numbers. Seven numbers, we have every other number. Man, so the pattern goes from 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1, 0. Is this right? For five numbers? Let's try. I thought we did it though, right? So for five numbers, it is, yeah, okay. It just looks a little different. And then for six numbers, is this for some reason, right? Okay, so then now maybe we'll just put this in a for loop, right? So I don't have to kind of manually do this, right? For I in range of, I don't know, 20, say, right? Like this. Do I see a pattern? I mean, this, I guess, but this is such a, I don't know what to do with this pattern, honestly. Right? I know that it has less than 20 whatever, but, and also, why not? So, is this helpful at all? This looks actually like whatchamacallit triangle. But I don't know how I'm going to use this to help. Three people's gotten it though, so apparently. There's a special name for this triangle. It's actually kind of cool, but I don't know what to do about this though. 4 in a row. Also, what does this mean? That means that has the contribution, and all the zeros means that they cancel out. And of course, it doesn't mean anything in terms of, I don't know. I mean, we could draw it more, but I don't see enough of it. Like I see the pattern, but I don't know how to pre-process it. It's actually a very cool pattern, but like Serpini's triangle or something. But I don't know what to do with it. Because we have to find, it's not even that we have to find this XOR score of this, which is already, actually that would have been pretty okay, but yeah, we could find, I mean, given this pattern, I guess we can figure out a pattern to figure this out, but it still doesn't mean anything for me. So okay, so the max number is fine, but then now you have these things that max to 14. How do you even get 14? Like how do I figure out that this, so 4 numbers, but 4 numbers is, I guess, all 4. But how do I even get that? But yeah, I might go make this bigger, but it just prints more things, which is not super useful. Like how do I look at this and be like, oh, yep, that's the ideal. I mean, okay, 1 is 1, 2 is 2. Like, is there a thing where like the answer is always 2 numbers or something? Probably not, right? Because you could create one with 4 numbers. Okay, let's actually look at the constraints. No, the numbers that goes up to 2 to the 33 plus 1, or whatever. I said it wrong. Whatever. Which means that the only okay. That was an int. Oh my god. Okay. And 16, and I assume 32 is good. So every power of 2 we have the thing. And what are these, and then it's just like 8 and then combine. Can we do a combination, like a bind? But then what about this part, right? How do you merge these things? I mean, I know that this is just like 1 0 1 0 and then merge, but man, people are smart. A lot of people got it though. I have no idea. No idea at all. I mean, I see a pattern of the XOR. Okay, so it's either 1 number or 2 numbers. Is that always the answer? No, because as I said, okay, you can have 4 numbers. You construct a case of 4 numbers, construct a case of 8 numbers, but you cannot construct a case of 7 numbers. But then you could do, can I do? And also like 1 and 5 is weird, or 1 and 4, 0 and 4, 1 and 5. So you skip 3, how do you even model that, right? I mean, yes you can. Can I do this and then this? So this, I see. I mean, I guess I see it, right? Because then now you get one number, and then you merge, so then now you have 2, and then you do it again, you have 3, so then you have an n squared type thing of max things, right? I see. I don't know if n squared is fast enough though, but I see. So you just do them all at the same time pre-calc, right? Yeah, and then you just do an RMQ on that, which is fine, right? Because then now, so this is just, yeah, so then, okay. I see. Okay. Whatever, just got it. I don't think that's the right name for it, but that's fine. Whatever. And now, and then now for the, yeah, that's not right. I'm missing a thingy. It goes up to n minus I, I suppose. Is that right? Oh, did I think I met, no, this is from something else. Okay. What I want is we print answer. Okay, so this is that the input? That is the input, the powers of 2s. I actually didn't realize that. Okay, so then that's 1, and then that's 2, right? Is that right though? Yeah, let's yeah, so let's try it then. I don't know if that's true. Oops. Okay, that is it. So it goes from I to J. This is not from I to J. This is starting at J after I iterations, right? Okay, so what does this mean here? You could get it, Larry, I think. Okay. What does this answer mean? Starting at J after I iterations. So that means that we want J minus I and starting at I. Okay, so that means that, so now we got this. Okay, that means that we pre-calculate correctly, right? And we could even just do, just for the funds. I think I did the wrong in the other one too. What is it? 2000? Oops. I mean, it's going to be n squared. That's fine. Maybe it's a little bit too slow. Also, we print too much, maybe. No, we only print one thing. But, alright, maybe that's too slow for here. Just because we do this thing. So, I think if we don't do this thing, it's probably fine. Let's just do a random thing that's much smaller. It also means that it is mostly correct, because if it's not, then the assertion would have been wrong a long time ago, right? Okay, so 100 works, so that means that this is now giving us the answer. So then now we just have to get the max. So within the query, then now we do RMQ, right? So we have sparse table. I'm gonna we don't even need to, right? Actually, I mean we can, but so J is after I iterations. So okay, so R is equal to okay, right? We don't need this anymore. How do I? What does this mean? What is IJ, Larry? IJ is J is starting at J after I combinations. Okay, so then now what does that mean? That means that best of J, best of JJ is going to be after 0, right? Iteration. Okay, so let's do this first, right? No negative numbers, right? Because that doesn't make sense. All right, this is not needed anymore. Okay, and then now we have to combine these after one iteration. Okay, so if I is 1, that means that is J and J plus 1, right? So J and J plus I is equal to best of J plus I minus 1. So that's the way it used to be, starting at J. Or answer sub Ij, and then now for each query, for SE and queries, I called the other thing the answer, so it's a little bit confusing. Best of SE. And hopefully we're good. Is that right? That is not right at all. How did I even get 123? This is, what is this? Oh, because I have this thing still there. Silly Larry. Alright, I mean, still wrong, but at least it's not impossibly confusingly so. Okay, so this is after 0 iterations, right? So that should be right. After 1 iteration, okay. Oh, after 1 iteration, so it's 1 and 2, okay, but then what's the best? I mean, we have 40 minutes, we should be able to do this. I mean, I guess that's why how people got it, but I am just messing up on the indexing, I think. Possibly, maybe worse. Okay, so what's 0.5? 0.5 is the max of all of these. right? So 0, that means that this is wrong. Why is 0, 5 wrong? 0, 5 should be best of 0, 4. Oh, there's another one, right? So it's best of, so then it's j plus 1, j plus I also. I think that's probably good too. Okay. Is this, I mean, it's right for the input, but is that the right answer, right? I don't know. This looks reasonable though, I think. All right, just YOLO. I mean, I don't know if this is quite right, but ooh, no, remove the print statements, Larry. Don't get the wrong answer for that. All right, I mean, at least we got the input, so let's give it YOLO. And there's no real reason why this should be, you know, okay, good. There's no real reason why like we should accidentally get the right answer for the input, is what I was gonna say. That was a tough one though, but I think I actually just misread this for a little bit, but thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest or this problem or everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.